Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking at a lot of exponential stuff. One big component here is exponent rules. So let's review a few of those right now. We'll cover some other exponent rules later on. One rule, product property. That tells us if you have two bases that are the same and those bases are multiplying, we can add the exponents. For example, x to the fifth times x cubed. When you multiply those variables, when you multiply the bases that are the same, you add the exponents. 5 plus 3 gives us x to the 8. If you have something like 2 to the x times 2 to the third, they're the same base, so we can rewrite this as one exponent, where again, you add the exponents because the 2's were multiplying. So we can make that 2 to the x plus 3. Same idea with power property. On this one, we have x to the fifth raised to the third. When something has multiple exponents, when a base has more than one exponent, what you do is you multiply. So x to the fifth raised to the third again, you multiply those together, giving us x to the 15th. So if I have something like 2 to the x raised to the third, well, that would give me 2. It has an exponent of x and 3, so both of those would multiply together, 3 times x or x times 3, whatever order you want to show there. Negative exponents have this property where they move to the other side of your fraction. So b to the negative n would be 1 over b to the n. We talked about why that was in class today, so if you want me to talk about that later on, come find me. We can look at that together. Okay, I won't necessarily go over that right now, though. So if I have something like 2 to the negative x, I want to move the 2 to the x to the bottom. The exponent becomes positive when you do that. And now we would just be left with a value of 1 on top. So that's just a few reminders of exponent rules. Well, one thing we can do is we can look at these exponential functions, identify whatever transformations are happening. Since these values are happening to the x, all of these transformations are in the exponent, they're all going to be horizontal transformations. For example, this first transformation, x plus 2, okay, it's adding, so we know it's a translation. It's plus 2, it does the opposite, so that would mean it's really going left 2 units. And then the next one, okay, it's 3 times x, so the opposite, okay, it's a dilation. Again, we know it's horizontal, so I'm not necessarily going to write that out right now. But it's a dilation. We need the kind of reverse of that, and we know dilations, we do the reciprocal, so 1 over 3. Okay, c, same idea. X over 2, that's the same thing as 1/2 times x, so it's a dilation again because it's multiplying with my variable. I need the reciprocal, though, for my dilation, so it's a horizontal dilation of 2. Looking at the last one, we're subtracting 1 from x. That would be going right 1. So that's the basic idea when we look at these problems, where you could find these different transformations of them. But there's this really cool idea with that, too. One that says, okay, if you have something like example A right here, where if you have 4 raised to the x plus 2, well, how did we get to that spot? How did we get to x and 2 actually adding? Well, let's go back to our exponent rules that we looked at so far. Okay, well, it's addition in the exponent. Addition in the exponent means it was something like this, where whatever the base was, it was multiplying, and whatever adding was the exponent on those two bases. So if I have x plus 2 as my exponent, I know that 4 to the x must have been multiplying with 4 squared. Well, since that is the case, then what I could do is I could end up changing this to be a different form. I could change this to be the form a times b to the x, where there is no transformation in the exponent. We can rewrite this to be a vertical transformation instead. Well, I can simplify this. 4 squared is 16. That's not a 6. 4 squared is 16. 4 to the x is still the same, but I want it in this form, so I'm going to move the 4 to the x to the end. That's one way we might change these functions. B and C, we'll talk about those more in just a moment. Let's look at D right now. Okay, I'm subtracting 1. Subtracting 1, though, is really just the same idea as adding a negative. So I might call this plus negative 1. Okay, but again, I'm adding in the exponent, so that meant that my base of 5 was really there 2 times. It was 5 to the x times 5 to the negative 1, right? When you multiply your base, that's the same. You add the exponent. So that's how I go between these two forms. Okay, well, 5 to the negative 1, it's a negative exponent. We said negative exponents move to the other side of our fraction. Okay, so I could make 5 to the negative 1. I can make that 1 over 5 to the first, which is really just 1 over 5. Okay, but we still have our 5 to the x. Again, we want it in the form that we looked at before, so 5 to the x is going to be moved to the backside of it. Those forms are the exact same, just shown using different transformations now. Very, very interesting. The other thing that we might do, though, these are the examples tied into B and C from above, where if you have this value of 9 raised to the 2x, well, your exponents are multiplying. And again, if we go back up to the top when we looked at that property, if my exponents are multiplying, that meant the base had 2 different exponents originally. Okay, keeping that in mind, well, my exponents are multiplying, so that meant originally my base had 2 different exponents. I had an exponent of 2 and an exponent of 9. Okay, but that's 9 squared. I know what 9 squared is. 9 squared is 81, and that's just raised to the x now. So I can again change the form of it. Very interesting. Example 4 as well. Okay, we have 4 to the x times 9. And oh my, there's nothing in the exponent that I can really do, right? There's nothing adding or subtracting. There's nothing multiplying with it. Let's look at our answers to utilize those. All of my answers somehow changed 4 to now be 16. Okay, well, what do I know about 4 and 16? I know that 4 squared is 16, but I already have 4, so I don't want to do anything to the 4. I want to do something to the 16. I know that if I took the square root of 16, that would give me 4. Okay, but I need exponents, right? I don't want just numbers. I need exponents right now. So one thing that we're going to start to talk about a lot is when you have roots, when you have radicals, what you can do is you can rewrite that as a fractional exponent. A square root is the exact same thing as the 1/2 power, 1 over 2. So, okay, that helps me now. Because if 4 is the same thing as 16 to the 1/2, I can change this problem. I can change the 4 to now be 16 to the 1/2. And since I replaced the 4, the x as the exponent is still there. But 16 now has 2 exponents. It has the exponent of 1/2 and the exponent of x. If something has more than one exponent, we know that we multiply those. Okay, so 1/2 times x, I still don't see my answer. 1/2 times x is just the same thing as x over 2. 9 times 16, 16 is raised to the x over 2. And now I have my final answer. Okay, so there is kind of the idea of changing exponential forms based off of what you're given, whether it's a horizontal transformation, a translation, a dilation, whatever's actually happening, and figuring out how to rewrite it. Last thing to talk about, this was one of the things that was confusing in class for sure. This is also the thing we just started talking about. When you have a square root, that's the same thing as the 1/2 power. Well, how that works is whenever you have a fractional exponent, there's 2 parts to it. The top part is your exponent. The bottom part is your root. So realize if I have something like 8 to the 2/3, let's look at that right now. 8 to the 2/3, that would be the same thing. The 2 is the exponent, so okay, 8 squared. The 3 is the root, so that 3 goes in front. And then I could simplify this. When you simplify this, it does not matter if you apply the root first or the exponent first to simplify this value. You could take 8 and square it first, which is 64. And then you could take the cube root of that. The cube root of 64, what times itself is 64. That would be a value of 4. Okay, but you could also do that the other way. You could say, okay, the cube root of 8 squared, right? The order you do those doesn't matter. So maybe you take the cube root of 8 and then you square it. Well, the cube root of 8, what times itself is 8. That's a value of 2. But I still need to make sure I square that value. I only applied the root so far, not the exponent. Well, 2 squared gives me a value of 4. And now I have my final answer. Okay, that's the idea of fractional exponents. That's called a rational exponent. The top is the exponent, the bottom is the root. Let's look at simplifying these so there is no negative exponents. This is weird, but let's do it. There's a bunch of rules. Apply one of them that we see. I notice a -1 on the outside. That means A has an exponent of 1/2 and -1. Z has an exponent of 1/2 and -1. Multiple exponents means I multiply them. So 1/2 times -1 makes it so both of these are now -1/2. Okay, negative exponent. I see there's a negative. Negative exponent means move it to the other side. So, okay, A to the 1/2 on the bottom, Z to the 1/2 on the bottom. We get a value of 1 on top now. And okay, now from here, I have 1/2 powers. It's a fractional exponent, so that means those are some sort of roots. The value on bottom is the root. The value on top is the exponent. So now I get something like this. Since they're both the same root, you can make them both under the square root together, giving us our final answer of 1 over the square root of A times Z. Looking at B, okay, I have the exponent on the outside again. Maybe I use that. X and Y and 81 are all multiplying together. So each of these things have their own exponent. The 81 has an exponent of 1 technically. So if I multiply that with 1/4, I get 81 raised to the 1/4. If I take my exponent with the x and multiply that with 1/4, I get -4. Same idea with the y. Multiply 1/4 and -28. Okay, do something I see now. I see negative exponents again. The 1/4 on the 81 is not negative, so that stays on top. But the x and the y move to the bottom because they were negative. Okay, 81 to the 1/4. That's the same thing as a root, we said. The root is the bottom, the power is the top. 81 to the first is just 81, so that's fine. The x and the y, those don't combine because they're different variables. Okay, so can I simplify anything else? Well, yeah, because you have the fourth root of 81 now. The fourth root of 81. What times itself is 81? That would give you a value of 3. Now we have our final answer, and this problem is done. That's a lot of information, a lot of exponent rules. We're going to continue to practice exponent rules because they are a very important part about mathematics. Thank you for watching. That is our 2.4 video.